Hello and welcome to Evolving Code. My name is Naresha. In this episode, we will learn a few tips about how to evolve our code by looking at the evolution of Java. In this particular episode, we will look at a particular case that happened between Java version 1.4 and 5. Java versions 1.2 to 1.4, those JDKs, they were all called Java 2, so they were called Java 2 SDKs. There were also other versions of distribution of Java like J2EE, J2ME, etc. But the core of Java was Java SE. So the title is Java, a case of punishing the punctual. What do you mean by punishing the punctual? Many times we have conferences, meetings or trainings, and some of us or most of us arrive on time. But then you would hear that it's great, you have come on time, let's all appreciate you by making you wait for the people who didn't manage to arrive on time. How does it feel? Definitely it doesn't feel good. Having been mostly a punctual person, I really don't like that kind of treatment, but sometimes unfortunately it happens. In this case, let's see if Java did that to the users of the language. The aspect of Java we are looking in this episode is string concatenation. Most of you must be already familiar with the Java's plus operator used for concatenating multiple strings into one string. There were certain performance issues when you try to concatenate many strings, and there were certain good practices suggested by Java experts, and one of such was mentioned in the book Effective Java by Josh Block. In the first edition, it's item number 33, which states don't use the string concatenation operator to combine more than a few strings unless performance is irrelevant. Instead, use string buffers append method. Well, here it says more than a few strings, but some people literally took it like you should never use plus operator for concatenating strings, and some of us received code reviews suggestions saying that don't use concatenation, instead always use string buffer. Let's look at an example. Here is an example where in the class concat I have written function concat, which accepts two arguments and just returns a concatenated string, and I'm using a plus operator to concatenate two strings. So if you literally take the previous recommendation and decide not to use plus operator here, we should use string buffers append method. Let's write a version using let's call it as concat with buffer, and we will create a new string buffer, right? Call it as buffer. Let's say put buffer dot append first, buffer dot append second, and then we will return buffer dot to string. Let's fix the typo there, concat with buffer. And most people started using second version instead of first version. Let's try to compile this with the JDK 1.4 compiler and see what happens. Well, since 1.4 is a very old version and it's hard to install in my Mac, I have installed it on a VM, and I have moved my code to this machine. You would see we have the original concat method that makes use of the plus operator for concatenation, and then we also have the newer version which is making use of string buffer, and the method is named as concat with the buffer. Let's ensure we have Java version, and yeah, it's 1.4. So let's compile with that. You see compilation has gone well. Now we have the class file generated. So let's use the disassembler java p minus c concat, and what we want to focus is on these two methods, concat and concat with buffer. So if you look at the original one which makes use of the plus operator, is still making use of string buffer under the hood. You would see string buffer dot append has been called twice, then toString has been called once, and I have also called append method twice on the string buffer. Then finally we are calling toString. As of now, it looks like the concat with buffer is taking more bytecode instructions compared to concat. Since I understand what's happening there, I'll slightly modify the way I have written concat with buffer. Okay, so let's rewrite concat with buffer in slightly different way by removing the unnecessary intermediary variables. Let's do it by calling it as, we'll start with the return itself, then we'll create a new string buffer. Then it's already giving a suggestion, but I want append first, right? Append second, and then finally toString. And now I don't need this. So let's move this back to the VM and check what our disassembler is going to give. Here is our updated code. Let's compile that. We should have that already. Now we could compare the two methods. It starts with the new, then a dupe, then calling the constructor of string buffer in both the cases. Then a load 1 invoke virtual for append, a load 2 invoke virtual for the second argument, then calling the toString through invoke virtual and a return. It's exactly same. By looking at the assembly code, we can say that when we make use of plus operator to concatenate strings, Java compiler under the hood made use of string buffer. This is in the case of JDK 1.4. Now let's compile the same code with JDK 1.5 and see what happens. I have updated to Java 5. Let's ensure that before proceeding. Now let's compile concat dot Java. Let's use the java p minus c concat. And number of instructions remain same, but interestingly, if you look at the method that used plus operator now makes use of string builder, and the other one, of course, I used this string buffer API, which will remain the same. Now, what is this string builder as against string buffer? JDK 1.4 had only string buffer, but in Java 5 we have string builder as well as string buffer. The string buffer, which was present originally, is thread safe. That is, if your string buffer object is shared across multiple threads, only one of the thread will be able to invoke append operation on it. The other thread will have to wait, so that we get consistent result in our string buffer fields. However, most of the time when we make use of string buffer for string concatenation and generate the accumulated string value, it is used within a single thread. It's not shared across multiple thread in most of the scenarios. Because of this, the additional instructions that were doing acquiring the lock, releasing the lock, etc., they were not of any use, and they were taking CPU cycles in our applications. So in Java 5, what the Java developers, I mean the people who produced Java, did is they introduced additional class string builder, which is equivalent in functionality to string buffer, but string builder is not thread safe. That way, if you use it within a single thread, it will offer slightly better performance because it does not its append methods are not synchronized, hence it has to do less job, right? That was offered as an optimization. Now this is an interesting situation, right? People who literally took the advice not to use concatenation and use string buffer, their code is kind of running slow in this case. Of course, it's a very primitive case, right? Not a case like append is used in a loop or used thousands or millions of times. Now you compare the situation what we have here to the situation when I discussed in the beginning when I said punishing the punctuals. So some of these developers who literally used string buffer everywhere, they felt like, okay, now Java has punished us. Oh, we use the best practices. Now we are getting less performance than those lazy people who did not bother to study about the better performance with the string buffer, right? This is an interesting situation. But let's ask this question: did the Java team did the right job, or they could have done something better? Imagine they had made string buffer not thread safe and introduced string builder as thread safe. In that case, there were lot of programs already using string buffer, and some cases did make use of capability to share string buffer objects across threads. So their program will start failing now when they compile. Of course, it will not fail when you compile, it will fail when you run, right? Since Java wanted to be backward compatible, they did not do this. So all the programs will run correctly even with Java 5. But if you need better optimization now, you had to go to your code base, figure out all the places where string buffer was used and replace them with the string buffer builder. Of course, wherever you are not sharing them across multiple threads, not in the case where you're sharing string buffer objects across threads, then it would remain the same. That's an interesting fact about what happened with respect to string concatenation from JDK 1.4 to JDK 1.5 or Java 5. Now that we understood how concatenation of two strings works under the hood in Java versions up to 5. In the next episode, we will try to understand what causes the performance problems when we try to concatenate strings. I hope you enjoyed this episode and learned something. Thank you for watching, and see you in the next episode.